Hi everyone, let's start Unit 3. Excuse me, we're going to start out, this unit deals with probability and it also deals with voting, a very timely topic. 7A is about the fundamentals of probability. Okay, so we're going to talk about 3 different kinds of probability and probability distributions and the probability of something not happening. Then we're also going to talk about odds in this as well. Okay, so this first one, the probability of an event is the likelihood of something to happen. It starts from, your probability goes from 0 to 1. And if your probability is 0, it's impossible. If it's, as it goes up the scale, it becomes more and more likely until your probability is 1. It's a certainty. So one of the things that we did in class and that you can probably experiment with on your own is flipping a coin. Okay. So you have 2 possibilities. You have heads or tails, and we want to figure out the likelihood of it landing on heads or it landing on tails. And so if you think about it, and if you have a fair coin, and that's really important, is it's not weighted or anything, chances are it's going to come up heads and tails pretty much exactly the same number of times. So let's talk about this. Now, I got this data from a class that I taught last year. And this is, I tallied up all the different groups, and they flipped the coin 30 times. So this first group got 7 heads or tails, and then 23 heads tails or tails heads. This is another group. Notice each of these columns adds up to 30. There were 10 groups, so we had, if we total them up, there were 137 out of 300 instances of heads or tails. There were 163 incidents of tails or tails heads. So it's not exactly even, but I don't know exactly what your answer was to part A, so I don't know if this is something that seemed likely to you or not. Okay, we're going to talk about 3 different methods on this. And the first one is relative frequency probability. This is based on actual observed data. And I'm going to call this method 1. And this is finding the probability based on what happened. All right, now how do we calculate the probability? The probability of an event is the number of times it actually occurred by the total number of observations. Okay. All right, so we're going to use this data here, and we are going to calculate the relative frequency probability that each player wins. Say the relative frequency that player A wins, the probability of heads or tails is going to be the total from this row. The number of observations is 300. And if you convert that to a decimal, that's going to be 0.46, or you can even write it as 46%. The probability that player B wins would be this row. There were 163 out of the 300, which is approximately 0.54 or 54%. So you can calculate the probability based on the number of experiments that you run. Okay. The second method here is going to be theoretical probability. Now, it's called theoretical because it is based in theory. Theoretical probability is based on what we would expect to happen. So this is going to be method 2. Based on what should happen. Now let's think about that. If you flip a coin based on what should happen, if it's a fair coin, you should get a 50% probability of heads or of tails. But that's not, if you look at the data, that's not exactly what happens. Okay, so on here, the probability event is the number of ways the event can occur based on the total number of equally likely outcomes. And that will make more sense as we get into some more examples. Okay, so let's see how that works. Since we don't have any data, we're going to have to look at what can happen out of the total number of outcomes. So let's think back on that same game where we tossed a coin, and you can either get heads heads, heads tails, tail head, or tail tail. Okay. So the probability of getting a head head or a tail tail is going to be one. There are 2 ways to do that. There are 4 possible outcomes, which becomes 1/2 or 0.5 or 50%. So there is a 50% chance that player A will win. Okay. Now let's look at the theoretical probability for player B. Well, heads tails or tails tails. So the probability of heads tails or tail heads, well, there are 2 ways to do that out of the 4 possible outcomes, which again is 1/2, which is 0.5, which is 50%. Okay, based on the theoretical possibilities, are the rules of this game fair? And a fair game means that there are that each person has an equal each player is equally likely to win. So the answer is yes, because each player has a 50% chance at winning. Okay, well, let's look at when there are more possible outcomes, and we're going to build up to more complex problems. A fair 6-sided die is rolled 1 time. It's fair, that means each side is equally likely to land. Again, it's not weighted or anything. It's just equally likely. Okay, so the die can land on either a 1, 2, 3, 4, 5, or 6. So this tells me there are 6 possible outcomes. So we know that's going to be our denominator. Okay, so let's see. What is the probability that the die lands on a 5? So the probability of a 5 is something over 6. Well, we're rolling a single die, So there is only one way for that to happen. So that's 1 out of 6. Again, if you want to convert this to a decimal or a percent, that's fine. Okay, well, let's see. The probability that it is less than 7, well, that's something out of 6. If I look at this, this is less than 7, 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 less than 7. So that is 6 out of 6, which is 1. This is again, we can write that as 100%, and this is what's called a certainty. If you roll a dice, one of the whatever number shows up is going to be less than 7 because it's only 1, 2, 3, 4, 5, or 6. All right, well, let's find the probability that it is greater than 7. Okay, once again, I know my denominator, my possible outcomes is 6. Well, there's no way. All the numbers are less than 6, so there are 0 out of 6, which is 0, or 0%, and this is what's called an impossibility. So all of your odds, all of your probabilities are going to be between 0 and 1. 0 is impossible, 1 means it's absolutely going to happen, and then everything else is in between. Okay. Well, once again, let's apply that to something a little bit where we have a bigger pool here. All right, this shows a standard deck of playing cards. Okay, there are 4 suits: clubs, spades, hearts, and diamonds. Clubs and spades are black, hearts and diamonds are red. Within each suit, there are 13 cards going from ace, 2, 3, 4, 5, 6 up to 10, and then the jack, queen, and king. So in each suit, you have 13 cards, and there are 4 suits. Okay. So the first thing I want to do is find out what my possible outcomes are, which will be my denominator. Okay. Which is how many different cards there are, so that's going to be 52. So I know from each of these that my denominator is going to be 52. It's going to be something out of 52. Okay, now you can mark this up however you want, or if that might be helpful for you as we get into stuff that's a little bit more complex. I may actually print out some more of these. And of course, this is so you can print them out as well if you want to practice. Okay, so the first thing I want to find is the probability of a jack of diamonds. So the probability of a jack of diamonds so that's going to be something out of 52. Well, there is only one card that is a jack of diamonds. So I have one possible way to do that out of the 52 possible outcomes. Now, if I convert this to a decimal, this is 0.019, which becomes 1.9%. Okay, let's go next to what is the probability that a card selected at random is read. Okay. Well, here are all the cards that are read. All right, so I want the probability of red is something out of 52. Well, if you count these up, this is 26 out of 52, which is 0.5 or 50%. All right, let's see. The probability that it's a heart. Well, where are all the hearts? They are these cards right here. You can see how messy this gets after I start marking things up a little bit. So the probability of a heart, oh, my hearts are awful, is something out of 52. Well, there are 13 out of 52. Which is 1/4, 0.25, or 25%. All right. So I'm hoping that as we go through these, you are stopping and doing these on your own. So the probability of an ace is, again, something out of 52. Well, I have an ace in each of the suits. So that becomes 4 out of 52, which is 1/13, approximately 0.077, which becomes 7.7%. Okay. All right. Now, if I want to find the probability of an ace or a king, all right, well, I've got my ace here and I've got my kings here. So there are 4 aces. There are 4 kings. So that becomes 8 out of 50. Whoops, I'm sorry. 8 out of 52. Which is approximately 0.154, which becomes 15.4%. Okay. I'm going to switch videos before we go on to the next one.